Now, you may not want to run away so fast because we have brought a very, very inspiring tech guru. He plays such an important role in Amazon. So our next speaker is a science researcher, an expert in computer science, and even a tech startup founder. Today, he's one of the key innovation figures behind Amazon, as I was saying. And he's well known for his predictions. What did he say for 2024? Well, new large language models will make generative AI culturally aware. Femtech will take off with advanced health technologies for women. That's something I'm certainly looking for and waiting for. AI coding assistants will help developers work faster by taking care of heavy lifting. And fourth, education will evolve to match the pace of evolving tech. We missed him last year, but he was finally able to come this year. Please allow me to welcome Werner Vogels, CTO of Amazon.
Good afternoon, Paris. I think if we look back at the past 2-3 decades, we as technologists and as in digital technology, but also in any type of innovation, we have had great success. Massive, successful companies, millionaires, billionaires. But I do believe that with that success and scale comes a really broad responsibility at the same time. If you look at the issues that we're facing in the world today, we as technologists have a responsibility to try to solve a number of the hardest problems that we see in this world. And yes, of course, if you think applying technology for good, these days, of course, you immediately start to think about how can we apply AI for good. And there's a huge amount of excitement around generative AI and things like that. But I would like to halt there and actually go back to a quote of one of the famous founders of artificial intelligence, John McCarthy, who said, as soon as it works, we don't call it AI anymore. There's a real big body of work out there that is actually AI, but that we don't call AI anymore because we only talk about AI in terms of looking forward, kind of things that we could be doing. And more importantly, I think it is also to realize that there is a massive body of work that works really, really well. We just don't give it that new stamp of AI, that AI that we've seen come to life in the past, let's say, year and a half. Yeah? And it's quite successful. But I think to really understand this, we need to go back in time, actually quite far in time. 3,000 years ago, Aristotle and Plato were already discussing about the use of intelligence to solve particular tasks by automation. And actually even to the point that Plato in the Republic actually described a number of humanoid robots that were performing household tasks. Remember, this is 3,000 years ago that they were already sort of envisioning what we actually have been coming to life in the past 10, 20 years. Now, most of those philosophers, and if you actually go back to the past 2,000 years, those who have been thinking about this artificial intelligence, they all still were thinking about that everything should be controlled by the brain. And that actually any thinking and any philosophy about that is actually driven by the brain. Now, brain was actually just, they thought that was actually manipulating symbols. So with the first arrival of computers who were also manipulating symbols, we really got to the point immediately to start to think about, can these machines actually think? Yeah? Alan Turing's probably our century's most famous computer science philosopher, really had this first question of, can machines think? And actually, the famous Turing test is made by Alan Turing. Can you distinguish answers from a machine from those given by a human? Actually, the word artificial intelligence at this moment doesn't exist yet. It is for the first time coined in 1956 in a workshop in Dartmouth with McCarthy there, Minsky, and quite a few others. But still they were thinking that artificial intelligence should be something driven from the top down. Basically thinking about sort of really how does the brain control the rest of the body. That didn't go anywhere yet. I think eventually symbolic AI, as we would call it, results in automated reasoning and many of the other things that are really successful areas now. But that was not what drove the success of AI in the earlier days. What drove the success was really thinking different. By the way, one of the things that we were building in those days, and yes, that is me, I had more hair in those days. I built a few of those in the 80s. We're using Prolog. But what really started to make a major change is the people that were actually working on robotics. They were saying, you know what? Why don't we do it top down from the brain down, but why don't we pick individual senses of humans and try to emulate those in technology? Yeah? Vision, sound, speech, all of those. And you really see that we have made great strides there because that actually was a path to success. This is a fulfillment center of Amazon.com. Yeah, we have about 175 of those around the world. And in each of those, you may see about 30,000 robots running around. And we can only do this because they can be autonomous. And they can understand different sensors. Not maybe, the robots are not necessarily speech-enabled, but they definitely have LiDAR and radar and other sensors that we as humans even don't have. Now, what we've seen over time is that we get all these different steps in technologies that slowly advance, and more of the underlying technologies drive the kind of things, the solutions that we can build with it. And of course, the last one, the most recent one, is that of transformers together with vector databases, which drive the generative AI world at this moment. Now, everybody's talking about large language models, and I will skip that for the most part, because I think many other people will be talking about that. Although it is actually getting a lot closer to Plato's dream. And the assistance that it can give in efficiency in areas like that is unparalleled. I do believe generative AI is just at the first 3 steps of a marathon in terms of impact on the solutions that we're building. It's very, very early days. And I also think that it's not the end of the implications of AI. We'll build newer underlying technologies, which makes other advances, again, possible. Which ones those are? We'll need to see in the coming 3 to 4 years, because that's actually the cycle in which we see underlying technologies improving together with the hardware that runs in lockstep. And especially the hardware part is extremely important. Because if you are concerned about technology for good, you also need to make sure that your technology is created in the most sustainable way possible. New types of chips, new types of programming interfaces will allow us to be sustainable and at the same time actually deliver new technologies. So I want to go to the area of what I would call AI for now. AI for now is a massive body of work. It actually all works, which, like John McCarthy, we then say, you know what, we don't call it AI anymore. But maybe the inverse of McCarthy's quote is that we call it AI if it doesn't really work yet. Yeah? But if you think about all that work that has been done, you know, can we actually use these technology to solve some of the world's hardest problems? Now, so what are those? I mean, the present is really important. Let's take all the technologies that we have, that we've created, and that make many of our businesses successful, but at the same time, we need to take the responsibility to use this technology to solve some of the world's hardest problems. And I wasn't really aware of that until, you know, quite some time ago, when I realized that, you know, some of the numbers that we're going to see in this world, the growth of our population, is disastrous for the current circumstances. You think about that in the coming 20 to 30 years, we'll see the population grow by another 2 billion people. That's an increase of 25% in the population. How are we going to feed them? How are we going to make sure that they're economically sustainable? Problems that even at this moment we already have. So what can we do in terms of technology? And I had been thinking about that for quite a while, how to organize that. And I think the UN Sustainability Development Goals are a right way to sort of segment the kind of work that has been going on. And so these are the goals set by the UN, but let's pick out a few of them and look at how young businesses, especially, are trying to solve these problems. I've been very fortunate indeed in the past 10 years, 10, 15 years, to travel the world and meet many startups around the world. One of the things that I started to see is outside, let's say, the main Western world, that many startups were not looking at becoming the next unicorn. They were really looking at solving some of the world's hardest problems. And I'm very fortunate at some moment to take a TV crew along to create this TV series called Now Go Build, that actually highlights these companies that solve some of the world's hardest problems. There you can find it on Prime Video and on AWS's website and on YouTube. But if you're interested in companies that are really solving hard problems, this is a really great TV show. But it also motivated me to look at sort of how can we use technology for good. So a really great example is this. Actually, one of my first episodes that I did was with a company called Hawa out of Jakarta. And if you think about Indonesia, or most of Southeast Asia, where there are many smallholder farmers, none of them have an identity. That means if you don't have an identity, you can't go to a bank for a loan. You have to go to the village loan shark, who charges 60%, by the way, to get some money to buy your seeds for your next crop. It means that half of your crop is already sold, gone, out of your hands, before you even start growing it. So they built this system that gives farmers an identity, measure their plot of land, measure the yield of that land, and then keep that data together to actually make that available to organizations that are interested in this data. The first organization, of course, that is interested in this are the banks. And why is that? It's because these farmers, they're not looking for $1 million loans. They're looking for $10 to $100 loans. And each of those actually have a 100% repay rate. So by just doing this, by giving these farmers an identity, by associating data with them about sort of the yield of their plot of land, all of these financial institutions are eager to support these farmers, something they would never had before. So now they can actually have a sustainable living. Why did this company actually start tackling this problem? Because they were children of smallholder farmers themselves. They understood the problems that their parents, that their communities are going through, and decided to actually take action and build a business out of that. Now, this is maybe what we call social impact businesses. Actually, not just you trying to do good, but have a good living and a good business at the same time. And this is possible because it's not the farmers that actually are paying Hawa. It is the banks and the government institutions that want to have access to the data that are actually making this business very successful. So if you think about one of the biggest problems that we'll have with 2 billion more people on this planet is access to food. And if you look at sort of the most important staple of food, is that of rice. Well over 50% of the planet is dependent on rice as their main food source. There's an organization in the Philippines called the International Rice Research Institute. They are absolutely brilliant. If you want to know more about sort of food research and things like that, absolutely look up what these guys are doing. They have the largest collection of rice DNA in their freezers, 200,000 strands of different types of rice. By the way, they're also backing it up in the north in Norway, in very cold areas. Now, their biggest challenge is actually taking in all of these rice and then sorting them, looking at which rice seeds are actually useful or not. And that is actually at such a high level that there's a huge backlog in actually getting these seeds into storage. This is one of these simple problems that you can easily solve with object recognition. Just use a small video camera, train it, and see which rice seeds can actually be useful or not. The longer these seeds actually kept out of storage, the bigger the problem is for them because they have to discard the rice. So a very simple system. Little camera, determining which rice seeds are good. And immediately by installing this system, which is not a magic system, but uses rock-solid, proven technology, they immediately eliminated all of their backlog. And they do a lot of research there, many different types. But you have to imagine that most of the farmers that they're targeting actually don't have cell phones. They can't read or write often. They can speak into a phone, though. So they developed a system for which farmers can actually call into, describe their patch of land and where it is. And then the system will give them advice about how much fertilizer to buy and when to apply it. Because most of these farmers have grown up with not much, let's say, scientific knowledge about how much fertilizer to use. They just buy a lot and apply it to their land. The same goes for pesticides. And so here, the key is that you're able to actually use voice as an access to digital systems. Remember, there's a very large part of this world where reading and writing is not common. And as such, if you want to give those people access to digital technologies, voice is critical in all of that. If you think about, indeed, about planting, most of not only fertilizer, but most of the biochemicals used to actually protect the plants are often just being sprayed. Yeah? Precision AI is one of these companies that actually uses drone with very high quality imagery to pick out individual wheat plants in rice plantations so that they can take them out and do individualized precision management of these crops instead of just spreading it over everything. The runoff often, both as well as the fertilizer, as well as these biochemicals, often run off in the rivers and actually create massive pollution and create an enormous amount of algae, for example, in these rivers. Now, that's rice. So what about protein? We kind of all like protein, and it's an important part of our diet. And so definitely, if the world is growing, how can we make sure that 25% more people have access to protein? The most efficient way to do that is to actually create fish. Because 1 kilo of fish feed results in 1 kilo of fish. If you want to do it with cattle, you have to give it 7 kilos of feed before you create 1 kilo of protein. And not only that, cattle farming has had a disastrous impact on many of our surrounding areas. So there's a company in Norway where I met them first, called Aquabite. And they have these massive pens in the fjords in Norway, where in each of those pens there is about 200,000 salmon in there. And they get in there when they're really small. And what they do, they use computer vision and object detection to track the individual fish, their growth, but more importantly, their health. Because one fish with lice in that pen will infect the other 200,000, and you'll have to destroy them all. And so they built this system, this vision detection system, together with things like saline levels and other IoT levels, to actually keep these fish healthy. And so this might be one of the approaches that are being taken to see whether we can, at scale, grow sufficient protein to solve sort of the upcoming disaster of not being able to feed everyone in this world. They have created these massive data stores already about how to actually sort of track fish and make that available worldwide. So if you look at some of the other areas in the sustainability goals, it's of course healthcare. How can we ensure healthcare for 25% larger population if we cannot even do it today? We as technologists are the ones that actually should stand up and actually find solutions to solve the healthcare problems in this world, or access to healthcare. Yeah. If you think about, at this moment, at 2021, I think, is a report by the World Health Organization, who estimates that about 2 billion that 2 billion people living in rural areas do not have access to healthcare at all. Things that we consider to be just a fundamental right to have access to it. Swoop Aero is one of these companies that are trying to solve how to get vaccines into rural areas. These drones, they're not piloted. They're completely automated. Drones are one of these examples of old-fashioned AI just working really well. A drone will easily have about 100 sensors on it. LiDAR, radar, vision. You need to be able to detect obstacles in flight. Because remember, these drones need to be autonomous. There's nobody sitting at the joystick to get this to a place where you want. And then when you arrive somewhere, you don't want to hit the dogs that are there, nor do you want suddenly this fishing line that actually was out there and want to run into that. So a lot of autonomous work using AI is being done to make sure that we can deliver vaccines into areas that have never actually seen any healthcare professional at all. And if you look at that, I think it was about a few years ago that I went to Brazil. And in Brazil, there's about 200 million citizens, and they consider that about 150 million of them are medically homeless. Dr. Consulta uses AI technologies to actually, first of all, provide very low-cost healthcare by looking at where the places in the world they can buy generic medicine for the lowest cost, but also make use of AI over patient records to start to predict what kind of health problems people may exhibit and try to intervene at a much earlier phase there. Sygenics in Ireland is a very interesting company. It actually turns out that about, 1 in every 200 newborns have some degree of brain injury. And these brain injuries are often not detected until months or years after birth. Yet with a very simple test, you can give it that. We now give babies a test whether they can hear well, whether they can see well, by just placing a little cap on their head, run an EEG, and then actually can detect these brain damages very early and immediately start to try and actually tackle those particular problems. Yeah, so they make use of EEG data. Now, why is that so important? Why can't we just do it regularly? It turns out EEG data of babies is radically different than that from us as adults. Now, in quite a few of the examples I gave you, computer vision plays an important role. And why? Because it makes nicer slides. But there's a whole range of other technologies that work really well and that are the foundation of how we actually applying AI for good. Whether it's natural language processing, speech, translation, all of these work well. These are technologies where you don't even think about anymore. Look at fraud detection. A company like Amazon, we literally sit on billions of orders from the past. We know which ones were fraudulent. And so we can build a model out of that. A new order comes in, it gives it a score, what the likelihood is that this is also a fraudulent order. We don't kill the order then. Actually, the order then goes off to a human investigator. Remember that AI predicts, but we make decisions. It is still not the case that these technologies decide for us. We are the ones that are in charge, and we are the ones that are deciding, where these tools just help us get to that decision. Now, in all of this, we cannot have good insights driven by AI if we do not have good data. And data is crucial in all of this. Now, the problem is often that data is a privileged asset. Companies holding them close to themselves. They're not opening it up. Although there's a lot of efforts going on to create more and more open data sets, having access to public data is crucial for those companies that want to do good in this world. A good example there is one of the other Now Go Build episodes that I did, which was in the Philippines. Now, the Philippines sit in what is called Typhoon Alley. They have natural disasters several times each year. But a significant portion of the country is what we call unmapped. And the question is even, do you exist if your street is not mapped? And why is it not mapped, by the way? It's because those companies that create the maps that we use on a daily basis are only interested in those areas that are economically viable. 80% of the Philippines do not fall into that category. So the Human OpenStreetMap Foundation actually tries to tackle that. They have people on the ground going through these unmapped areas and mapping them by hand. And also indicating, especially with respect to earthquakes, which buildings are actually stable. And mapping that out. The Red Cross in the Philippines lives by this data set. Because that's the only data set they can get their hands on to actually reach people in need during these disasters. So I honestly believe one of the biggest challenges we have at this moment is to make sure that we can democratize access to this data for good. There are many organizations already doing that. AWS, the cloud computing arm of Amazon, for example, has a large collection of open data. One of them is Digital Africa. This contains imagery over the years from 3 large satellite grids. The one from the US, from NASA and USGS. There's a European one from the Project Copernicus. And JAX, the Japanese satellite company, also makes these digital imagery available. So you can look for the deterioration of mangroves. You can look for illegal roads being built, because then that's probably at the end of the road, illegal mining is happening. So making sure that we have this data available for everyone is actually crucial in improving access to data. Now, why is this data so important? Why is it different from the past? I think one of the major changes that we saw, let's say in the 90s, we already knew what kind of questions we wanted to ask, and that drove what kind of data we collected, SQL queries. But with cloud computing, making data storage so cheap, suddenly you could keep all your data around. And then it becomes sort of a massive heap of data where you're looking for the pot of gold that may be in there. Now, what is the technology that you use to find the needle in the haystack? That's a magnet. Yeah? In this particular case, to find the needle in a digital haystack, you use AI or machine learning as the technology. That is crucial. Now, I want to leave you with a last example, which I think is most telling. There's an organization called FORN. It's a non-profit organization that has as a goal to stay ahead of child sex trafficking and other child sexual abuse. They use image recognition, they use data mining, they use collaborative filtering, all these different techniques to prevent and detect child sexual abuse. They built a system called Spotlight, in which they have imagery of missing children from all around the world. They compare it each day, for example, in the US, against the 100,000 new ads for escorts that are being released each day. And Spotlight has been quite successful. They already found 18,000 victims of child sexual trafficking and rescued, and more than 6,000 were actually very young children. They built a different system called Saver, because I assume none of us here would like to have child sexual abuse material on our servers. If you have any way for your customers to upload imagery, you may want to use Saver to find those images. that they have a massive database of sort of hashes of this imagery, and they can detect this for you. Many of these organizations have actually used humans to do this. Believe me, if you need to look at these images just for a day, you will need therapy at the end of the day. If we can actually scale this up by using technology and actually really find this imagery and actually nip it when we can, that's crucial. They also actually make use, Safer is also a tool that can actually look at communication patterns between individuals and look for patterns of grooming. These technologies are crucial if we want to solve some of the hardest problems in this world. Now, good AI needs good data. There's a symbiosis between the two. And that means that good data absolutely needs good AI to be able to make sense of it. But more importantly, good work needs good people. It is us as technologists with the right mindset to want to solve some of the world's hardest problems, because we've been successful in actually solving spam filters. Let's make sure that we can solve a number of problems that are much harder than that. Talking about good people, this organization called Tech to the Rescue actually launched a program called AI for Changemakers. It's a global accelerator that focuses on different areas of tech for good. And I think they are running this year 5 different cohorts in different areas. Jumping on that, I've been so impressed by this program that today I'm announcing a CTO fellowship, the Now Go Build CTO fellowship, because I believe that many of these innovators in this space can actually make use of sort of the experiences that I and my team have as driving technology for so many years, that we can actually help them with that, with this CTO fellowship. And really, technology plays a crucial role in technology for good. And to find out more of the fellowship, by the way, and for the AI for Changemakers, look at the, capture the QR code there. So I'd like to leave you again with McCarthy's quote. Yeah? Remember that some of the current technologies is clearly that of what I would call a dancing bear. We really are amazed that this bear can dance. We're not really looking at whether the bear dances well or not yet. For that, we need some longer time. So as soon as it works, nobody calls it AI anymore. There's a massive body of work out there that you can use to solve today's hardest problems. Now, I'll leave you with this. Yeah? Now go build. Thank you very much.